Let us discuss about the problem, that is design strength of the member. Okay, that is they have given directly the member size. Based on the member size, we are going to calculate the design strength, that is how much load it is going to take. Okay, that we are going to calculate right now. So the problem is determine the design axial load carrying capacity of the column of ISHP. They have given on section. So ISHB 300 at 577 Newton per meter. Okay. And the effective length of the column they have given as, sorry, the length of the column they have given as 3 meter. Okay. And they have given that the both ends of the columns are pinned or hinged. Okay. Both ends are pinned. So these are all the given data. Let us find design axial load. Design axial load carrying capacity of column. Okay. Now let us move on to the solution part. Okay, first of all, we need the sectional properties such as I, there is moment of inertia, area. So I also with respect to z axis and y axis, how much? Okay. Similarly, okay, these properties we need. Okay, so that we can get it. That is similarly breadth of flange, okay, height, then thickness of flange. So these things we are need, and we have to calculate those things from the handbook. Okay, let us move on to the handbook first. So here the handbook, okay, now they have given the section as ISHB 300 at 577 meters. So ISHB, we have to search it here. ISHB, okay, ISHB 300 at 577, correct? So here they have mentioned the unit weight, okay? So based on that, we can choose, that is we can find this section, okay, now 58 kg per meter, okay, now which is nothing but 577 Newton per meter, okay. So now the area they have given as 7485 centimeter square. So into 100 gives the area in mm square. So like that, okay. So we have to choose these things. Okay, we will see another things also. Okay, now like so we can note it down. So for ISHB 357.7, okay, now for that the area is 7485 mm squared, and the depth of the section H becomes 300, and breadth of the flange, the total B is equal to 250 mm, BF is equal to, then thickness of flange becomes 10.6 mm, okay, then thickness of flange we need. After that, IXX is equal to 12,545.2 centimeter power 4. So into 10 to the power 4 gives answer in terms of mm power 4. Similarly, IYY, so 2,193.6 centimeter power 4, okay, now so from this we are going to calculate rxx and ryy value, okay. So we can calculate these things, okay. So based on that we are going to choose the buckling class, okay. So let us go to the calculation part. So from the handbook, okay, ixx or izz both are similar. Okay, now ixx value becomes 12,545.2 into 10 to the power 4 power 4. Okay, similarly iyy is equal to 2193.6 into 10 to the power 4 power 4. Similarly, area 7485 74.85 into 10 to the power 2 meter square, square. Okay. Then breadth of the flange is equal to 250 Height of the section is equal to 300 Then thickness of the flange is equal to 10.6 Okay. So as per their sheet, 10.6 Okay. Now let us go for the rxx and ryy value. That is radius of gyration value. So radius of gyration, okay, with respect to xxxn is equal to I by a, we know that. So ixx by a. Similarly, ryy is equal to root under iy by yy by a. So from this, if I'm going to substitute, what is the value I'm going to get it? So root under ixx12545.2 exponential power 4 divided by area 74.85 into 10 to the power 2. So 129 129.46 So next IYY, that is RXX value we need. So 2100 and 2193.6 exponential power 4. Then the value becomes 54.13. 54.13 So they have given the value of RXX and RYY. Okay. Next, what we need, we have to find out the buckling class. Okay, now, or else before that we can go for now we have to find out the buckling class. Okay, so this is an I section. Okay, this is an I section. So for the I section, what is the buckling class category? Okay. So here we are having the buckling class categories. So how to calculate the buckling class from table 11, okay? Sorry, from table 10. So here the buckling class. So height by BF we have to calculate first, okay? H by BF. So H value we know that 300. Breadth of flange is equal to 250. So the value becomes 1.2, less than or equal to 1.2. So here the value is less than or equal to 1.2. Next, the thickness of flange is 10.6. Okay, now, so here it can suit up for our value. Okay, that is with respect to least value. Okay, now with respect to z and yy. So which one is the least radius of gyration comes under IYY, okay, that is RYY. So our buckling class is going to have under buckling class C, okay. So this is the thing which we have decided right now. So first of all, H by BF, okay, from table 10 of IS 800 2007. H by BF is equal to 1.2. Okay, next thickness of flange is equal to 10.6 mm. This is less than equal to 100 mm. So if it is okay, now we can have two categories, Z categories, which is nothing but XX. Okay, another one is YY category. So among them, which one is least radius? So here we can have least radius of gyration under the YY axis. Okay, so our buckling class, here we can have B and here we can have C. So with respect to least radius of gyration, our buckling class lies under class C. Okay, so the buckling class lies in C, since the least radius of gyration comes in YY axis. Okay, next, from the formula of code book, okay, PD is equal to AE into FCD. Okay, so AE, we are going to have direct value here. There is no bolt or nut, what they didn't mention anything. So 7485 mm squared, we are going to take it directly, but the FCD value we have to calculate. So FCD value we can calculate in two terminal. Okay, now one is directly from table. Okay, now, and another one using formulas. Okay, so we are going to see all the two categories. Okay, first we should move on to the table category. Okay, so I will share the code book right now. So here the code book. Okay, so buckling class comes under C, correct? So with respect to yield stress, always we know that a Fi is equal to 250 Newton per mm squared. Okay, that we are going to write it here. So KL by R, so KL, what is the KL value and least radius of gyration, that we have to find out now. Okay, so I am writing here. So from table, okay, we need KL by R value as well as Fi value. So Fi, we all know that always it is 250 Newton per mm square. Okay, then KL by R is equal to how much? K value is nothing but 1 into L, because of our support conditions. Okay, R is least radius of gyration, so RYY here. So RYY value becomes 54.13. Okay, so here 1 into L is nothing but 3000 divided by 54.13. So the value of KL by R is equal to 3000 divided by 54.13. So 55.422. 55.422 is the value of KL by R. So corresponding to this value, what is the value of FCD? That we have to check it from the table. So from the table 9C, okay, the value of 55.42, we can take it as 55. Okay, for 50 it is 183 FCD value, for 60 it is 168. So in between that we can have 55. Okay, by taking average we can find out. So 183 plus 168 divided by 2. So 175.5 is the FCD value. Okay. So from table 9C, from table 9C, okay, from buckling class C, we are going to use table 9C from IS 800 2007. By using that, we have found that FCD value is 175.5 Newton per mm square. Okay. Now we are going to substitute directly. Okay. Now therefore design compressive strength. Design compressive strength of the member PD is equal to AE, that is 7485 into FCD 175.5. So the value becomes 1313.62 kilonewton. So this is the design strength of the member. Okay, using table. Okay, next we are going with the formula. Okay, so next we are going with the formula. Okay, you can choose either any one, either by table or by formula. Okay, now which one is comfort for you, that you can use. Okay, now we should move on to the formula. By using formula from IS 800 2007. Okay, so how, what is the formula? So I think we have seen lot of formulas. Okay, same we are going to have like this. There is PD is equal to, here we have the formula PD is equal to AE into FCD, whereas FCD is equal to Fy by gamma m naught divided by 5 in 5 plus 5 square minus lambda square power 0.5. Whereas phi is equal to the formula, lambda is equal to what is the formula, then FCC is equal to what is the formula. So these things we have to find out right now. Okay. Let us go for the solution using the formula. Okay. PD is equal to AE into FCD, whereas FCD, okay, first we should go from bottom. Okay, now E, we can take it as a steel structures now, so we can take it as 2 into 10 to the power 5 Newton per mm square. Okay, E value, and Fy is equal to 250 Newton per mm square, and Fu is equal to 410 Newton per mm square. So this is the constraint we can have. So these values have been assumed values. Okay. So next from IS 800 2007. Okay, what are all the things, formulas? Phi is equal to 0.5 into 1 plus alpha into lambda minus 0.2 plus lambda squared, whereas alpha is equal to, okay, now that is we seen in table 7 now, so that is our alpha value. So alpha value for the buckling class C, table number 7. Here alpha for the buckling class C becomes 0.49. Okay, so that we are going to take it. So from table 7, of IS 456, alpha becomes 0.49 for buckling class C. Okay. Then next we need lambda value. So lambda is equal to Fy by FCC root under. Okay. So FCC is equal to pi squared E by KL by R minimum the whole square. Okay. So pi squared into E value is 2 into 10 to the power 5 divided by KL by R. So KL value is 3000, okay, by R minimum 54.13 the whole square. Then the value becomes, okay, 642.63 Newton per mm square. So next to that, what we are going to find out? We have to find out the value of the value of lambda. So lambda is equal to root under Fy value 250 and FCC is 642.63. Then it becomes 0.62. Okay, now therefore phi is equal to, okay, 0.5 into 1 plus alpha value is 0.49 into lambda value 0.62 minus 0.2 plus 0.62 the whole squared. So if I am going to substitute this value, I can get the value of phi. So phi becomes 0.79. Okay. Therefore, FCD value. So FCD, we are having the formula, that is Fy by gamma m naught divided by phi plus root under phi squared minus lambda squared. Okay. So Fy is equal to 250 divided by gamma m naught value is 1.10 from table number 5. Okay. Then phi value is 0.79 plus root under 0.79 square minus lambda square. So lambda value is 0.62 square. Okay. So that the value becomes, FCD value becomes 177.61 Newton per mm square. Therefore, PD becomes, so AE value we know that from the handbook we have calculated that 7485 mm square. Okay. So 7485 mm square multiplied with 177.61. The answer becomes 1329.41 kilonewton. So this is the value of design strength. Okay. So by using any one method, either formula or by table, we can find out. Okay, now there is no much deviation in this. Okay. So this is the problem which related to design strength of the member. Okay. Next, we should move on to design of compression member. So the section also we have to design based on the applied load. Okay.